Something I forgot to mention with intramembranous ossification is the fact that because there's only a primary ossification center, this leads to bones that have to be sutured together or fused together over time. So we have what's called soft spots or fontanelles, okay, in between the bones of the skull, because all of these bones develop via intramembranous ossification. And so we have these soft spots or these fontanelles, and the reason for that is it serves a purpose. Yes, the cranium, eventually we want these bones to be fused together and hard so that it protects the very important brain, but early on, what's more important is being able to pass through the birth canal. So these soft spots allow for the skull to be more flexible, more pliable. It can pass through the birth canal more easily. And then also, after birth, once the baby gets exposed to lots of stimuli, having these soft spots allows for rapid growth and enlargement of the brain, leading to more intelligent individuals, right? So that's why it's the bones of the skull and the cranium, really, that develop via intramembranous ossification. Yes, the bones aren't fused together at the end, and you have to ossify, complete ossification later on, but we get larger brains because of it. Okay. Next is endochondral ossification, which is going to be all other bones below the head except for the clavicles. Clavicles are the only bones below the head that develop via intramembranous ossification. Endochondral also begins during fetal development within the womb, right? And we'll see that not all bones are completely ossified through endochondral ossification. A lot of them will ossify over time as the child grows. And so many bones complete ossification by age 7, except for areas of like the growth plates, which we talked about. Growth plates are the little strips of hyaline cartilage found between the epiphysis and the diaphysis of long bones, allowing for lengthening of those long bones. All right, so endochondral ossification, again, starts with a slab or a model of hyaline cartilage. Hyaline cartilage is going to be more pliable than, say, bone is, and so we can build and remodel upon hyaline cartilage a little more easier than if we were to just lay down bone right away. Because we're starting with a slab of hyaline cartilage, we're going to see it is specialized hyaline cartilage. You'll see chondrocytes with cartilage extracellular matrix. You'll see perichondrium, all of that stuff that we talked about when we discussed hyaline cartilage in Chapter 4. Not only do we see a primary ossification center in endochondral ossification, we see secondary ossification centers as well. The primary will be in what will eventually become the diaphysis, and the secondary ossification centers will occur in the sites that will eventually become the epiphyses.